Good morning, grade 7s. My name is Siseko Duli. I will be presenting algebraic equations with you today again, guys. Thank you. Right, we are going to do algebraic equations now. Now, my lesson outline is as follows, guys. First thing, we are going to identify prior knowledge or a quick recap on what has already been covered in the algebraic expressions. That is the first thing that we're going to do so that we can link the two so that you understand where we are going. And then we are going to talk about algebraic equations. We are going to explain what's an equation, since I believe, guys, it is still new to us in grade 7. We are going to differentiate between an algebraic expression and an algebraic equation. Then we are going to write number sentences to describe problem situations. We are going to write number sentences to describe problem situations. So you will see when we get there, what do we mean by that and how it's going to be done. So basically, that is all that we're going to cover today, guys, with you regarding the algebraic equations. Let us delve into it then. It's going to be nice, guys. Believe so. Right. Algebraic equations. What is an equation? First thing, we need to ask ourselves, what is an equation, so that we can understand what we are talking about. In simple terms, we say an equation is the formal word for a number sentence. So we are getting away from number sentences. Now we are getting to the new words, which is an equation. Write an equation. So we'll move away from writing a number sentence, meaning that you guys, as you go through to other grades, you are going to do grade 8, you are going to do grade 9, you are going to do grade 10, and so forth. So you will now no longer be familiar with the word number sentence because you'll be more familiarized with the formal word, which is an equation. So we are going to touch on that a lot. Then, how do we then understand the difference between an equation and expression? How do we understand the difference between an equation and expression? Let us see. First, guys, we have already explained what is an expression. Just to do a quick reminder there, we say an expression, as previously discussed, is a mathematical phrase that contains ordinary numbers, variables like x and y, and mathematical operations like addition, subtraction, multiplication, and division. And an equation or algebraic equation is a formal word for a number sentence. So how do they differ? How do we differentiate that this one is an equation, this one is an expression? How? Let us see. So an algebraic expression does not have an equal sign. So when we talk about expression, we have to understand again that an expression will not have an equal sign at all. It will be just an expression like that, like 2x plus 3x. There is no equal sign there. So it means it is an expression. But while an algebraic equation have an equal sign between the terms, so the equation will have an equal sign between the terms. Typical example would be 2x plus 3x equals to 4. Or 2x plus 3x equals to 2x plus 6. Can you see that? So there is always going to be an equal sign between the terms. So, for example, now let us start. In this essence, we are given a number sentence. We are writing number sentence to describe a problem situation. The problem is 2 times a certain number p. That certain number has been given a variable there, guys. Careful. 2 times a certain number p decreased by 8 is equal to 12. Let me write it, guys. So it is 2 times a certain number p decreased by 8 is equal to 12. 2 times a certain number. So let us look at it. 2 times a certain number p decreased by 8 is equals to 12. 2 times a certain number p. So let us analyze this situation first, guys. So the first thing there, we've got 2, we've got times, we've got a certain number. Forgive my spelling, it was a certain number. 2 times certain number. 2 times certain number p decreased by 8 again equal to 12. Now, those highlights that I've made there, guys, let me do this one as well. Number. Now, those highlights that I made there, guys, they are going to help me because first thing I must understand, what must I do? First, let me write it in short, guys. 2, as in a mathematical way, or in a mathematical language, or when I'm writing my equation in this case. All right, let me just go back a bit. 2 times, let me read the situation again. 2 times a certain number p decreased by 8 is equal to 12. There is equal. The word equal, it means that I'm talking about an equation now. I'm no longer talking about an expression because it's got the word equal. It highlights to me, it gives me that I'm going now to talk about an equation. Right. Now let me write my equation. Can you see my terminology has changed, guys? I'm no longer saying let me write my number sentence. I'm saying let me write my equation. My equation will be as follows, guys. 2 is a number. So let me represent it as a number, not in words. So 2. Then they say times. Times is a multiplication sign. A certain number p, a certain number p. This number that I don't know, it has been given a variable p. So it's going to be 2 times a certain number p. That certain number, it has been given a variable which is what? P in this case. So I'm no longer having now to say my variable will be x because in this case it has been provided that it is p. Then what else is given to me? They say decreased, meaning that I minused. How much? 8. It has been given to me as weight. Then 8 as a number, I write it as a number, is equal to 12. So it is equals to 12. Right. So this is a typical example of an equation. Why? Because it has got a variable. It has got a constant. It has got a coefficient. And then it has got an equal sign. And there's also a constant on the other side of the equal sign. So this means that I'm dealing now with an equation. So this is how my equation will look like. So in short again, guys, remember we said 2 multiplied by p is the same as 2p minus 8 equals to 12. So this is how it's written. 2 times a certain number p is decreased by 8. Decreased by 8 is equals to 12. So this is my equation. So as is now, it becomes an equation. Can we see? So 2 times a certain number p decreased by 8 is equal to 12. So I broke it down and I wrote everything. I underlined all that I'm going to use. Can you see everything that has been highlighted there, guys, or underlined? I used it because 2, there is 2. Times, there is times. A certain number p is a variable. Decreased minus 8. is equal. Equal has been underlined. Equal is there as a sign now. We know how to write it as a sign. Why again do we know all these things? Because we understood our mathematic vocabulary. Failure which will give us problems, guys. Again, as a word of advice, let us always understand our mathematic vocabulary. Right. So this is how we wrote our equation. Maybe later on we will solve them. But now let us just be confident on how we can be able to write them as equations. Right. Let us take a look at this one. This one, it says a mother is twice as old as her daughter. Now, how old is the daughter if the mother is 64 years old? Right. Now let us take a look at this one. A mother is twice as old as is twice. The word twice there is going to help me, so I'm underlining. As old, so I don't know. It's an unknown. My unknown there is twice as old as her daughter. Now the question is, how old is the daughter if the mother is 64? So in this case, the mother is equals to what? 64 years. I'm told that the mother is 64. So let me start. Twice is 2. As old, twice as old, I don't know. So it's going to be my unknown. So I will gladly write my unknown as x. So it is twice as old is 2 mania. So I will write the sign multiply because it's 2 more or it's twice old. So the word twice old means that whatever the mother is, whatever the daughter would, let me say if the daughter is 5, it means that the mother will be twice the age of the daughter. So it's going to be 5 times 2. So it's going to be 10. So it is twice as old. So twice as old. So twice as old is 2 times more than the daughter. Now, it's going to be 2x. 2 multiplied by x. And then the mother is, in this case, it says a mother is twice as old as her daughter. Twice as old. As old, you don't know yet. Before we go to that one, we did not know. As her daughter. How old, the question then comes, how old is the daughter if the mother is 64? So we know now the age of the mother, which means the mother is equals to 64. So it's going to be equals to. Can you see? So the mother will be what? 64. So how do we then write it? So we knew, we were given the word twice as old. Twice as old, which we don't know. But now we know. So the one we don't know now is the daughter. Now we are told the mother is 64. The daughter is the one we don't know. So when we write it in short as an equation way, it's going to be 2x equals to 64. Why? Because the mother is told, we are told that the mother is 64 years, but the daughter is not being given to us. How old is the daughter in this case? So the one that we don't know, it becomes an unknown. An unknown is going to be the variable x, is if it is not being provided which alphabet to use. So we always use x to make things simple for us. Right, so this is how then we break it down so that we can write a number sentence. I'm sorry, an equation in this case. We no longer now going to talk about number sentences. Oh, we can talk about number sentences, but the most important part is that now we are moving away from number sentences. We are now formalizing everything to equations. So this is how we write it, guys. Right. So guys, before I carry on to the next slide, again, we write equations in many ways. I just want to take this lesson with you guys and do this one so that in most cases, like the ones that we just did now, let me just bring this slide back. So the ones we just did now, we're given number sentences, and then from these number sentences, we're supposed to write equations. Again, now, if we have written those equations, sometimes it may not be provided in a number sentence like this. It could be a situation of a table where we can analyze it and be able now to say, let us formulate our own equation to solve the problem. So let me take you through that example. Let us say, for example, we have a square, a polygon here, which is a square. Then we have my squares are not drawn to scale, guys. Then we have a third. Then let me do this, and then let me write my table. And I will say number of polygons, or let me just say squares, and then number of sides. Number of sides. And then it's going to be 1, 2, 3, then 4. Then let me say here we are going now to have nth and tha. Right. Now let us take a look at this exercise, guys. My example here. So here we are given the number of squares. We've got, in the first pattern, we've got 1 square. Here, how many squares? Here we've got 1. Here, how many squares? 1, 2. We've got 2 squares. Here, 1, 2, 3. We've got 3 squares, and so forth. Now let us calculate the number of sides in each square. In square 1, let us say we've got 1, 2, 3, 4. So there are 4 sides. Square number 2, we've got 1, 2, 3, 4, 5, 6, 7. We've got 7 sides. In square number 3, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 sides. And then the question comes here and say, then how many sides will there be in number 4? Somebody would decide, we may decide, we've got many ways to do it. The longer way would be, we can draw the squares 1, 2, hence we can see the pattern here. each time they add a square. So it means there won't be 3, there will be 4, which means they are 4. So we'll count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we know that it's going to be 13. But let us say before here, then they ask us in square number 35. Now, if we've got 35 squares, how many sides will there be? Now, does it mean that now we're going to always draw up to 35? Or we have to think about another way? No, guys. This is where now the equation that we're dealing with in number sentences are going to come to help us a lot. How? We have to now come up with a formula, because they may ask us to discover how many sides will there be when we have 99 squares. Now imagine if you've got 99 squares that are combined like this. How are you going to? You're going to draw 99 squares? Again, you won't be having enough time. Imagine, think about the time and everything in between. So we have to come up with a way in which how we can find the numbers here, or we check what could be the relationship between 1 and 4, 2 and 7, 3 and 10, 4 and 13, and so forth. If we could be able to find the relationship, then we can be able to now say, okay, let us develop our own formula so that whenever we are asked any question, we can be able to come up with a solution. Now, that means that if we see the word nth, it means create your own equation so that you can be able to calculate anything that could be given. Now, how do we start by creating our own equation? First thing first, we would have to ask ourselves, what is the difference between 7 and 4? 7 minus 4 gives us how much? 3. And then again, we check again the difference between 10 and 7. 10 minus 7 gives us again 3. Again, the difference between 13 and 10. Again, it is 3. Now we can see that we've got a constant number there, meaning that they are constantly adding 3. So it means that if we were to ask, or if we were to be asked in number 5, how many sides would there be? We'll just add 3 to 13 and get 16. And even when we draw it, we'll see that there will be 16. But now, how do we create our own equation using this information? First, let us say S here will represent the number of the squares. And then N will represent the number of sides. Now, we'll take these 3 as a difference that we get. Then we'll say 3. When 3 is multiplied by S, it must give us the number of, give us the number of sides. It must give us what? N. But now, before we can do anything, we check it if that can work. We do our own estimate. We say, okay, if I take these 3 and multiply it by the number of sides, in the first one I've got 1. 3 multiplied by 1 equals to 3. But the sides are not 3 there. And I put aside and I say, okay, how about if I say 3 plus 1? Right. Or 3 plus S. S standing for the number of squares. So it's going to be 3 in square 1 plus 1 equals to 4. Voila. Yes, it works. Let me check it again. The second square. 3 plus is going to be what? 2 equals to 5. No, this does not work. Now, we need to change our approach. It means that this plus, it cannot help us. 3 multiplied by, we said first we're going to say 3 multiplied by S, which is side. When we multiply by S, it gives us N. But in the first one, we've got 3 multiplied by S, which is 1. It gives us 3. It does not give us 4. Meaning that we are short. From this 4, we are short. By how much? By 1. To give us what? To give us 4. So we can say 3 multiplied by S plus 1 equals to n. And check if it is going to work. 3 multiplied by s. S is 1 in the first one, which is 1, plus 1. It's going to give us what? N. 3 multiplied by 1 is 3, plus 1 equals to 4. That seems to be working. Let us check if it's going to work. This equation that we just created in the second one. 3 multiplied by s. S is 2 in this case. There are 2 squares, plus 1. 3 multiplied by 2 is 6, plus 1 equals to 7. Yes, it is correct because n is 7. Checking again the third one. 3 multiplied by s plus 1. 3 multiplied by, the third one is just got 3 squares. 3 squares and then multiply by 3 plus 1. Because 3 multiplied by 3 is 9. Plus 1 equals to 10. Oh, now this equation that I just said I created here is working. Meaning that I may now stop drawing these boxes and use this equation. I may stop drawing these now and use this one. Why? Because this is going to help me. Imagine if I were to find 35 squares on how many sides are there. Now, if I've developed my own equation to work out the outputs, then it's going to make things simpler for me. Why? Because I would now say, if they're asking me how many sides are there in 35 squares, then combined like in this case, then I wouldn't draw these squares up to 35. What I would do, I would just apply my equation and say, okay, it is going to be 3 multiplied by s. They said how many squares? 35. So I'll say multiply by 35 equals to plus 1 equals to my number of sides. Now, mental math wise, this can be done in many ways. We can either say 35 multiplied by 3 or 3 multiplied by 35 is the same thing. 3 multiplied by 5 equals to 15. In 15 we write 5, we carry 1. 3 multiplied by 3 equals to 9, plus 1 equals to 10. So it's going to be 3 multiplied by 35 is going to be equals to 105 plus 1. So it's equals to my number of sides. So 105 plus 1 is going to be 106. So my number of sides is equals to 106. Right. So guys, when we are given number sentences like this to create equations, we highlight the important information that we can use first. Or it may come in a form of, let us take it the next slide, in a form of this. And if we understood the one that I just provided as an example there, guys, it may help us to come with our own or to create our own equations when we are given situations like this. For example, let us look at the following polygons and identify the relationship between the number of polygons and the number of sides. So, here, again, let us see. Number of polygons and the number of sides. Right. So I'm just redrawing this table as it is given to us, guys. 1 here, 2, 3, 4, and then this set nth, meaning that we need to create our own equation when it says nth. And then let us say, for example, 40 here. So these polygons are octagons. Combined together. Right. Let us take a look. Now, these are the polygons that are given to us. Now, we need to now create our own equation to solve this thing, to solve this situation. Say, for example, here, this is polygon number 1. How many polygons here? There is 1. Here, there are 2. They are octagons. Why? Because they've got 8 sides. Here, they are 3. We can see they are combined. Now, in the first, how many sides? Number of sides. Let's count the number of sides. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. So this a shape or a polygon that has got 8 sides. We know it's an octagon, guys. So it has got 8 sides, the first one. The second one, let us count the number of sides. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the second one has got 15 sides. And then we write it. Then the third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. It has got 22 sides. Now we are asked to find the fourth one and come up with an nth, the equation of this, and then find how many sides will there be in the 40th, or if we've got 40 polygons or octagons combined. Now, remember guys, what we spoke about earlier on when I was providing an example. I said the first thing that you need to do when you develop your own equation, you take this 15, you minus this one. So 15 minus 8 equals to 7. Then again, 22 minus 15 equals to 7. By the virtue of seeing this, guys, we can see that now it appears that 7 is going to always be a constant number, or they always add 7 to get the next one. So it's going to be 8 plus 7, 15. 15 plus 7 equals to 22. There we go. Then we start saying, okay, this is going to be a polygon. This is going to be represented by the letter P, because it stands for polygons. Number of sides, let us change this one. It's going to be number of sides. It's going to say S. So when we develop our formula, we take the difference between the number of sides, or the output in this case, the number of sides, which is 7. Then we're going to say our 7 must be multiplied by our number of polygons, the ones on top, which is P in this case. So it's going to be 7 multiplied by P. Now, after having done that, then what do? We check. We test it so that we can see, do we supposed to add or we supposed to subtract something from there so that we can get the output, the anticipated output. So in this case, when we substitute P with the given value of the first polygon, we would say 7 multiplied by 1 equals to 7. But here our output is not 7, it is 8. So it means that this 7, we short something so that it can give us 8. So we start by saying, okay, what if we say our equation will be 7 multiplied by P, I forgot to write equals to number of sides. P plus, we short 1, equals to sides. This is our equation. Let us test it if it works. We say, okay, 7 multiplied by p. P in this case is 1, which is the number of polygons, plus this 1. This 1 is the one that we just add so that we can see whether it works. We are testing it. Now, equals to number of sides. 7 multiplied by 1 is 7 plus 1 equals to 8. So, is the number of sides equals to 8 in this case? Yes, it's correct. But before we can conclude that this is correct, we test again on the second one. It's okay? Let us use it on the second one, this equation of ours. This equation of ours that we created. 7 multiplied by p plus 1 equals to s. It's our own equation that we created. Where did we take 7? On the differences between these numbers. Where did we say p? Why do we multiply by p? Because p is always our polygon, in this case is given. And then s is always the number of sides. In this case we have said, okay, the letter s will help us as a number of sides. We cannot write the whole thing here. Right, plus 1, this one is the one that we just added so that we can see, will this equation of ours work? Before we conclude that this is correct equation. So 7 multiplied by p on the second one, 7 multiplied by the second one, how many polygons do we have? 2 plus 1 equals to s, which is number of sides. 7 multiplied by 2 equals to 14 plus 1 equals to s, which is number of sides. So 14 plus 1 equals to 15. Voila. So we can see the second one it gives us as well. Let us test it again, because it may give us the first and the second, but it may not give you the third. If it gives you the first and the second and the third, then it means you can be confident that yes, your equation is correct. You can be able to apply it to find other unknowns. Right. So we say 7 multiplied by p plus 1 equals to s. Why? Because this is what we have deemed it to be our equation. Right. So it's going to be 7 multiplied by p, in this case the polygons equals to 3 plus 1 equals to sides. So 7 multiplied by 3 is 21 plus 1, 22, which equals to s. And our number of sides, indeed, they are 22. So we are confident now because everything has been proven using our equation. Then we can confidently say our nth term is 7p plus 1 equals to s, which is number of sides. Remember, 7p is the same as 7 multiplied by p. Right. Now, if we are asked to find the fourth one, so we'll just substitute. We say 7 multiplied by p in the fourth one is 4 plus 1 equals to number of sides. 7 multiplied by 4 is 28 plus 1 equals to s. 28 plus 1 is 29, which equals to s. So the number of sides here will be 29. And then let us check it if it's correct again. We said they constantly add 7, add 7. So if we want to know the second one, we'll just say plus 7. 22 plus 7, yes, indeed it gives us 29. So we don't mind, we don't worry, even if they can say find the term number 40 in this case, or the polygon number 40. So it's going to be simpler for us because why? We just apply our equation. What is the equation? 7 multiplied by p plus 1 equals to s. So 7 multiplied by, they said it's 40. So polygon number 40, we substituted 40 plus 1 equals to s. So I always encourage my learners, guys, that whenever we see something like this, we don't have to be afraid of anything. We just say 7 multiplied by 4 is 28 and put this 0, because 40 by 7 or 7 by 40, it will give you definitely 280 plus 1 equals to s. So 280 plus 1 is going to be 281 s. So here, if they're giving us 40, then our number of sides will be 281. There we go. So out of this lesson, guys, the most important thing is how do you develop or create your own equation using this table or the table that has been provided for you with the polygons, squares, or any information that may be provided to you. So how do we develop your own equation? So in most cases, again, I'll go back there to start recapping. Remember, we said that the first three in most cases, they may be provided to you. What do you need to do? You need to use them to create or develop your own equation. How do you do that? You just take the second one and minus the first one. 15 minus 8, 7. And then take the third minus the second. 22 minus 15 equals. Then the minute you see something is constant, it does not change, then automatically you're going to take it, use it as your first point of reference to multiply by the relationship of the items that are given to you on top. Right. So now we have done them. We have found the polygon where there are 4 polygons. We were able to find it, and then we have also find the nth or the equation of this information. We were also able to find the equation of this thing. And then we were also given that, let us find, say, for example, a polygon where we've got 40 polygons. How many sides will there be? Also, we succeeded in that. How did it become successful? Remember, guys, because we were able to create our own equation to define or represent the information on this table. So the equation, again, it helps us a lot. It helps us to be able to find all the outputs or all the number of sides, as in this case. They may be given to you as 100 or 99, 78. The minute you have created your own equation, everything becomes simpler. Right. Unfortunately, guys, we have come to an end of the lesson for now. And you guys have been wonderful. I hope you guys will practice. Please, guys, let us practice and practice. You know, most of the time when we do maths together with the teachers in class, everything seems to be simple. But the minute you start taking your pen and a paper and start writing, things now tend to be different. So I will encourage you guys to practice. Practice, guys. Take your time. Redo everything that we have done together so that you can be able to see where the gaps are, where the problems are. And don't be afraid. Don't be shy. Ask questions. You only learn when you do ask the questions most of the time. Thank you very much. Thank you.